I'd like to welcome to the stage Linda May Zhang from Blue, California.
Okay. All right. Hello. My name is Linda May Zhang. I'm a Research Science and Innovation Officer at Blue, California, and I am very happy to kick off the Business First stage of day one of IFT. I'm super happy to see everyone in person this year. And so today I am very excited to talk about an important topic, food and health. And I need to figure out how to use this. Okay. All right. Okay, so today we're going to be talking about titanium dioxide replacement solutions. That's why you're here. But I want to kick off the stage to talk about something first, and that is the power of nutrition. This is the first talk of this stage, and I want to talk about nutrition first. So by training, I'm a biomedical scientist. I spent my past research career focusing on how food components influences health. And so I was originally trained as an engineer, became a gut physiologist through my PhD, did work in pharmacology, studying antioxidants, dietary antioxidants, gut microbiome, and cardiovascular disease. But nothing has really illustrated the power of nutrition until the birth of my sons, shown on the screen. And witnessing the power of milk being the only food source to transform their growth through the first months of life. It's been miraculous, it's magical, even the second time around, and this is Jaden, my 3-month-old. And so we know food influences our growth, our health, our energy levels, even our genes by the way of epigenetics. We also know that consumers are becoming more aware and knowledgeable in terms of nutrition, making food choices that favor health. But we also know that there's many factors to consumer choices besides the knowledge of nutrition. Food has to be tasty, even healthy food. The molecules in food responsible for taste perception stimulates our brain. Food texture, even food odorants influences taste processing. And even before taste and smell, we know at this conference that consumers taste with their eyes first, before taste and smell. The colors that they see influences their taste expectations and sensory experience. So they see the green mint leaves and they think fresh. They see the red berries and the blue berries and they think they're going to eat fresh, healthy berries, even though they might not be aware of the health benefits of the berry pigments, anthocyanins. They see the white yogurt and they automatically presume creamy. And so color plays an important role in the early experience of the consumer. And it's not just about color perception. It's not just about the color white per se. It's about the consumer association of that color with previous experiences that they're used to. So they already know about, green vegetables, bright berries, white milk cream, and they already have expectations set early in their experiences. So an example of this is I am a soft serve ice cream fanatic. I absolutely love soft serve ice cream. And so when I'm standing in line, at the buffet, whatever, I always eyeball the next person's ice cream. I see how white it is and I see how opaque it is. Why? Because if it's not opaque and white, I think it will taste like ice milk. I don't know how many of you realize what I'm saying, but ice milk and not ice cream. And so it is about color, because that makes me want to buy ice cream if it's actually satisfying my previous experience of what it should look like and what it should taste like. And so that's why today we're focused on not only health, but also, more importantly, the importance of having beautiful foods that we're used to seeing, and specifically on the color white. And so, as many of you know, we all know that Europe right now, with the exception of the UK, no longer supports titanium dioxide as a food additive. And because of mostly the concerns of safety involving titanium dioxide nanoparticles. And so this phase out is happening now, leaving many food manufacturers scrambling. And even though we're talking about Europe, we're seeing this phase out happen globally. A number of US food chains are phasing out and stopping selling food that contains titanium dioxide. And even without this legislation, we know that consumers are paying more attention to food labels and what's in their food. These consumers want clean label, they want simple ingredient lists that seem fresh, natural, perceived to be nutritious. They do not want synthetic chemicals, they do not want synthetic ingredients, and when asked why, according to an IFIC survey, the top reason why they don't want synthetic chemicals is that they are concerned about health. And so consumer awareness is at an all-time high, with health being top of mind, especially during and after, hopefully, this pandemic. And consumer awareness is playing a major role in the demand of food additives and other associations of food. And oftentimes migration of consumer trends happen from one side of the pond to another. And so now let's talk about titanium dioxide. So I want to spend one moment talking about how titanium dioxide whitens so well. So first of all, titanium dioxide, as we know, is a very effective whitening pigment. It's very versatile. It's been used in many food and beverage matrices. It's also used as a pigment in sunscreen, as an active ingredient in sunscreen, and also a pigment in paint. And so how does titanium dioxide work so well? I want to take a moment to explain that, because then you understand the challenges of finding or innovating a titanium dioxide replacer, because I know several of you might think it's been very challenging to find a replacer. So titanium dioxide, first of all, has a high refractive index. Refractive index basically is a unitless measure of how light bends, how a particle bends the light. So you have a matrix with titanium dioxide, light hits the surface of the matrix, and titanium dioxide particles basically bend the visible light back to your eye, and that's why you see white. That's why that's part of light scattering. And so when a particle has lower refractive index, light doesn't bend so much back to your eye, and that's why you see less white. And so the scattering of light also depends on the matrix. So I'm showing here the refractive index of the particle, refractive index of the matrix. The matrix is basically the material that you're putting the particle in, whether that's air, water, oils, yogurts, smoothies. So the bigger the difference between the refractive index of the particle and the matrix, the better the particle is at scattering light, basically, and you see white. And so that's why when you have, say, starch, you mix it in sugar and you put it on a powdered donut, you see white very, very well. You put that same starch in water or another matrix and you no longer get that whiteness. It's because it relates to the properties of not only the agent that you're using, but also the matrix that you're using. And so titanium dioxide has a high refractive index. It's chemically inert. It doesn't react chemically with the agents surrounding it. That's why you could use titanium dioxide very effectively in many applications. And finally, the food-grade titanium dioxide on the market that has the right particle size to scatter light. There is an optimum diameter to scatter light, to scatter visible light. And it depends on the wavelength of visible light. So I show you here, the optimal particle diameter is about half the wavelength of visible light, which ranges between 400 to 700 nanometers. So titanium dioxide has the right particle size to scatter light. So if you exclude the nanoparticles, that ranges between 200 to 300 nanometers. So titanium dioxide has the right refractive index, it's chemically inert, and it has the right particle size. And that is why titanium dioxide is so effective at whitening and very versatile. And so despite titanium dioxide being so effective, the limitations are, obviously we're going through an interesting period. There are safety concerns given that a fraction of titanium dioxide products are nanoparticles. And also consumers are more savvy these days. They do their research and they might question the use of titanium dioxide in foods. And finally, there are formulation challenges, potential formulation challenges with titanium dioxide. Titanium dioxide is heavy, it has high density, and so it can tend to precipitate. And also titanium dioxide tends to agglomerate. And so because of those properties, there's concerns that techniques to redisperse titanium dioxide causes the formation of nanoparticles, so that feeds back into the safety concerns. And so the perfect design of titanium dioxide alternative is that it should include both the strengths of titanium dioxide as well as the value attributes that titanium dioxide has limitations in. So obviously, titanium dioxide alternative should have excellent whitening power, should be versatile, but it also should have absolutely no compromise in safety. It also should be label friendly, and it should have ideal properties like being easy to redisperse and have little or no precipitation. And so we at Blue California are very excited to present to you our alternatives for titanium dioxide. Here at IFT, this is the first public demonstration of these technologies. And we're excited to present to you a series of whitening solutions that are completely versatile and customizable to your finished product. So we've designed these titanium dioxide replacement solutions to be made exclusively from materials already found in food. So there should be no reasons why they are not considered safe. And to address any other concerns, these whitening agents are also free from nanoparticles. And if you don't know who we are at Blue California, we are an entrepreneur-spirited company that values science, research, and innovation. We value human health. That's why I'm here as a biomedical scientist. And we serve the needs of our customers, who then can serve the needs of our consumers. We're all about service for goodness, and that's why our tagline is capacity for goodness, because we have endless capacity for goodness. And so now I'm going to show you data demonstrating the effectiveness of our whitening agents in a variety of applications. I know some of the product formulators and food formulators out there are waiting for data. I could spend all the time talking, but it's all about the data to show the effectiveness. So a variety of applications I'm going to show you is gelatin, pectin, chewing gum, and coffee creamers. Briefly, I'm going to cover yogurt, pudding, baked goods, as well as film coatings for packaging. So let's begin. All right, so first, gelatin applications. So I'm going to show you two sets of data. First is pH neutral, and the second set is acidic pH. And we're using 6% gelatin as a model system, but applications include Jell-O, gummies, even beverages with gelatin. So first, we're looking at pH neutral. So we're comparing two Blue California whitening agents, shown in this green box, against common alternatives like calcium carbonate, cornstarch, rice starch, and calcium sulfate, all at the same concentration. And so you could see that our whitening agents not only effectively whiten compared to calcium carbonate, but you can also appreciate that cornstarch, rice starch, calcium sulfate have very poor whitening power. And so, and you could also appreciate that our whitening agents disperses evenly and remains in suspension in this gelatin matrix. So this set of data shows that our whitening agents whitens effectively, redisperses evenly, and remains in suspension. So here is a close-up of those same gelatin cubes. So basically you just plop out the cubes, and what was on the bottom now is shown on top. And you can see that our whitening agent in the very first cube shows, first of all, great whitening power, uniform dispersion, and no precipitation. But we're also showing you titanium dioxide as the middle cube. Titanium dioxide obviously can whiten, but the problem is it can tend to precipitate without special redispersion techniques. The third cube is calcium carbonate, and okay, it looks good on the screen. I'm like looking at this and I'm like making sure that you can see the particulates on the big screen. You can see very clear precipitates with calcium carbonate. So the take-home message is that even though titanium dioxide can effectively whiten, the limitation is that it cannot remain suspension very well, whereas our whitening agent can suspend very evenly. Next, we're looking at gelatin again at acidic pH, pH of 3. So this would be the case if you wanted to make gummies that are acidified at the end, for example, and you wanted to add a white color like these gummy sharks. So here we're looking at the same gelatin model, 6% gelatin suspension, now at pH 3. And so I'm comparing titanium dioxide against Blue California whitening agents with increasing concentrations, and you can see that our whitening agents can not only effectively whiten, but also remain stable at pH 3. And this is important because the alternative, calcium carbonate, is known not to be stable at acidic conditions. If you mix calcium carbonate, put it in acidic conditions, it basically creates carbon dioxide gas. So it's not stable at all. So the fact that our Blue California whitening agents can effectively whiten and remain stable at high acidity makes these whitening agents suitable for a variety of applications beyond gummies. It could be applied to matrices with high acid fruits, acidic confectionaries, high acid beverages as another example, especially when the acid serves to extend shelf life, high acidic protein gels or beverages with protein. So just to illustrate further how significant these data are, we're working currently with a candy manufacturer that has tried many alternatives on the market, and none of them have worked for their high acid, high temperature application. And they tried ours, and it's worked. So that has demonstrated the effectiveness of our whitening agent in their confectionery that requires high acid and high temperatures. Okay, so now we're looking at pectin. So gelatin is a product developer's best friend, but pectin is the next best thing when we're looking at plant-based foods and plant-based confectionaries, for one example. So here we're using 1% pectin as a model system, and shown in the teal box, our whitening agents again can effectively whiten and remain in suspension in 1% pectin. Whereas you could appreciate rice starch and corn starch tends to settle and by nature cannot effectively whiten. Titanium dioxide also tends to precipitate in this pectin matrix. You could see clearly the precipitates on the bottom of this cup, and this cup is having the liquid poured out. So you could actually see the particulates is not super saturated or we use too much, and you could see that we're using 0.5% titanium dioxide. And so like what I've shown you earlier, the limitation of titanium dioxide is without special techniques, it has, it's heavy, it has high density, and it tends to precipitate, and it can tend to be hard to formulate in pectin and gelatin-based matrices or just aqueous matrices in general. Okay, so next we're looking at chewing gum, which represents one of the larger categories that uses titanium dioxide. These prototypes, I know they look like tablets, they're compressible chewing gums, and we use a tablet machine to make them in our lab. And so can you guess which one has titanium dioxide and which one has our whitening agent? And I asked that question because you can't guess because it doesn't matter. You can't tell a difference. And so we're actually working with a company right now incorporating our whitening agent in their chewing gum base. And we've gotten excellent feedback on the white color enhancement. But in addition, we've gotten feedback of a more pleasant taste experience with our whitening agent. So in this case, our agent can enhance color, the whitening color, but also enhance the consumer sensory experience. Okay, so next is coffee creamers. So milk cream is white, and you could achieve lighter looking coffee by adding more cream. Non-dairy creamers and low-fat creamers have a limitation in that they can have ingredients to achieve that creamy mouthfeel, but sometimes the coffee, when you add the creamer, just kind of looks like a brown sludge. And so here is an experiment we've done in-house. We compare black coffee with creamer added at a 3-to-1 ratio. That is quite a bit of creamer already, for me at least. And you could also see coffee with creamer added, with also our Blue California whitening agents added. So it looks like, if you look at the whitening agents added, it looks like you've practically doubled the amount of cream added, but it's really the addition of a very small amount of whitening agent. So you could achieve lighter looking coffee with a lot less creamer. And so along with the 4 applications I just showed you, we've tested many other applications either in-house in our lab or given them to our customers to test. And here I am just showing you an overview and a summary of our in-house results. We've tested in yogurts, in puddings, in baked goods, as well as film coatings for food packaging. And you can see that our whitening agents can effectively whiten with little or no precipitation, I would say no precipitation issues compared to the original product. And very importantly, there has been no changes in the consumer sensory experience, which is very important. And so even though this is a food meeting, I just wanted to show you that the possibilities are endless beyond food. You can see whitening effects in eyeshadows and lip balms. So this is advantageous for the cosmetic industry. You could see whitening effects in natural toothpaste as well as laundry detergents. So the possibilities are endless also with our whitening agents beyond food. And so I hope through data I've demonstrated today that our whitening agents have excellent whitening power. They are safe, made from materials already found in our food supply. They are customizable, as in we're here to serve the customer needs and are happy to work with you to innovate the best solutions for your specific product. That's an advantage of working with Blue California. They are customizable. They are also label friendly, vegan, non-GMO, and not made from artificial ingredients. They precipitate a lot less or have no precipitation compared to TiO2. And finally, they are stable. I've shown you data to demonstrate pH stability, but they are also heat and pressure stable. They've sustained high temperature UHT as well as 30-minute boils at 150 Celsius. And they've also sustained high pressure to up to 30,000 PSI. And so along with the alternative whitening agents at Blue California, we're continually innovating technologies that really meet the demand of consumers, but also of our customers too. So for example, we're showcasing a couple of technologies here at IFT, and the booth is S1668. We're working on nature-based food preservatives to replace synthetic chemicals like BHT, because we know consumers are moving away from wanting artificial ingredients and chemicals in their food. We're also working on molecules found in nature that have research-supported benefits. One example is healthy aging, whether that's related to brain health, bone health, skin health, digestive health, combating oxidative stress. So we have proprietary manufacturing processes that are bio-based to provide a high purity ingredient rather than botanical extraction of these molecules. And our ingredients are also GRAS approved. Several have FDA no objection letters, so these ingredients are perfect for, say, functional foods and beverages. And also showcasing here at IFT are natural flavors and fragrances, because we know consumers want natural versus synthetic. And finally, I wouldn't say finally, but one of our other capabilities is offering encapsulation services among other services we offer at Blue California. So the possibilities of innovation are truly endless here, and the sky is truly the limit. So let's collaborate to develop beautiful foods for better health using our alternative whitening solutions to address this current safety concerns of using titanium dioxide. Or check out the other capabilities I just mentioned, because in the end, we want to give consumers the same beautiful and tasty foods they enjoy eating, but ensure the safety of food for better health. And my name is Linda Mei Zhang. I want to introduce our scientific lead and inventor of these technologies, Dr. Cui Yan. Her email address is up on stage here, and you could email her for any technical questions. She's unfortunately unable to attend this conference because of an overlapping conference. But I do want to introduce an innovative scientist, Jordan Farmer here. I'll have her stand up. She's going to be manning our Blue California booth. She has product demos so you can see in person our whitening agent, and she's here to answer any technical questions.
Excellent. Thank you, Linda. We're running a little bit short on time, but we do have probably time for one question. Now, my colleague Corbin is out with a microphone. If you have a question, please raise your hand. How about the
Okay.
person right here in the end? And speaking of the microphone, please, for our online audience.
The question I have is how it will be labeled at the ingredient statement.
So the ingredients are they're clean label, non-GMO, but right now they're proprietary, and so we're working with customers right now to test for efficacy first, and then we'll work together for labeling. And you can talk with us at the booth.
Thank you. Excellent presentation. Your presentation was titled Overcoming Regulatory Hurdles, and I was looking forward to hear from you if there was something with FDA or any other regulatory agencies that you need to register this product. And especially the claim is this is safe, but is there, I mean, I didn't see any data showing this is safe in comparison to titanium dioxide. So those two things, if you can clarify, that would be great. Thank you.
Okay, so we as a company can't comment on FDA, but our regulatory team can provide a statement to our customers ensuring the safety of our materials, because they are, right now it's a proprietary blend, but we can ensure the components of our agents are 100% already found in the food supply. So we have confirmation that they are safe.
All right. Thank you, Linda. I think we are at time. Obviously, if you have further questions, we would definitely encourage you to go visit Blue California over at booth 1668.